So yeah, hi team. I'm Shravani Manne. We are from Group 22. Our team members are Shering Lama, Lakshmi Priyanka Vemula, and myself. So today I'm going to give presentation about paper 1, which is a roadmap of agent research and development. So coming to this paper 1, I researched about autonomous agents and multi-agent systems are evidence that complex software systems should be analyzed and designed in such a way that from large systems to small systems, these are going to be analyzed, designed, and developed. And few characteristics of agents are being overly promoted, which will have an undesirable consequence similar to what artificial intelligence has faced. And coming to the key issues and how they are interrelated, there are like 3 types of key issues. One is situatedness, autonomy, and flexibility. So situatedness is something where agents can perform action which changes like sensory input from environment. And coming to the autonomy, here the system acts without direct intervention of the humans. And flexibility, here the system is responsive and act in a timely manner. Coming to the characteristics of the system, there are again like 3 types: responsive, proactive, and social. In responsive, agents respond in timely manner, and in proactive, they behave as per goals in appropriate manner. And coming to the social, these artificial agents and humans interact each other to try to figure out their own problem and help each other. And on an overview, these agent-based systems are implemented without any structures and which can design a system in terms of object. Hence, agent-based systems are to be designed and implemented in terms of agents. And coming to the autonomous agents, it is again divided into 2 subparts. One talks about history of autonomous agents and the other talks about future of autonomous agents. So AI mainly focuses on the behavior of human body, like learning, writing, speaking, and how the problems are being solved by the agents. And during the research into AI and automation, a research named Brooks found out a procedure for making agents like by understanding like overall attitude, and which is typically performed by agents, and studying the result of the multiple agents' behavior. Over to Priyanka.
Hi everyone. Today I like to discuss about multi-agent systems. Originally, the research on these multi-agent systems was taken under the name of distributed artificial intelligence. This distributed artificial intelligence has been split into 2 groups. One, distributed problem solving, and next, multi-agent systems. This distributed problem solving is also a subfield of artificial intelligence, which deals with the interaction of multiple intelligent agents. And next, multi-agent systems. As the name itself indicating multi, it discusses about the systems composed of multiple components. It is also a core area of research under contemporary artificial intelligence. Next, intelligent agent. It is an entity which which makes a decision and enables the artificial intelligence to take an action. So these intelligent agents plays an important role in these multi-agent systems. Next slide. Next, characteristics of multi-agent systems. There are many characteristics. First one is each agent has a limited viewpoint. What it actually means is no agent has the complete information to solve a particular problem. And autonomy. Every agent is independent of its own activities. Local view. No agent has the global point of view. Only limited information. And data is decentralized and complexity. And some other characteristics of multi-agent systems are adaptability. These agent activities are adjustable to the environmental changes. Next is regarding history, how the research has been started, and all other things are detailed explained in this. First, deep research about this artificial intelligence has begun in the early stages itself, almost that is in 1980. Actually, in these difficulties relating to intelligent problem solving with systems containing multiple problem solvers has been taken. A group of researchers conducted first workshop at MIT, one of the MITs, to explore difficulties in these multiple agents. After doing a series of researches, they have designed two models. One is actor model. In this model, system communicates by the asynchronous message passing. There are three basic primitives in this actor model. One is create, second is send, and third is become. In this create, actors have been created, and send information is sent to the actor through the send primitive. Next one is become. In this actors local state has been modified. And next one is the contract net protocol. Actually, this was designed by the David and Smith. In this, task allocation was done by this protocol. Next, industrial applications. There are many industrial applications where agents and its technologies has been applied. Some of them are listed here: air traffic control, manufacturing, process control, etc. In air traffic control, OASIS, a technique has been followed. And process control, they are normally explosive systems. And in manufacturing, one second. And few these are the industrial applications. Next slide. Next, commercial applications. We know in this technologically advanced world, everything is related to information, and the information on internet and world wide web is very large. What I actually mean to say is enormous. And next, lack of efficient management tools. Information overloading problems have been arising. These information overload problems are classified into two groups. One is information gathering and second one is information filtering. This information gathering has been handled by the Maxim's technique, and information filtering has been handled by the Warren's technique. And in a technique named adapt has been used to tackle the business process management related problems. Next slide. And other applications. These multi-agent techniques has been playing an important role in the entertainment field too. These games and interactive cinemas and theater, computers are playing a very important role. And in medical applications, in patient monitoring and healthcare systems, Guardian system has been used, uh, which was very helpful in the ICU, intensive care unit tasks. Over to Shravani.
So coming to the conclusion, this field of multi-agent systems are rapidly expanding in research and development over the past 2 decades. And they are also involved in multiple implementations of both design and testing parts. So furthermore, like these technologies are also improving their way into commercial products, and also they are also really helpful in real world software solutions. Over to Lama.
Hi everyone, my name is Chiling Lama. My paper was about multi-agent learning for engineering. And in this paper, we are addressing the question if multi-agent learning is the answer, and what is the question then? Just like the name, multi-agent learning uses different agents to assist in the design of a complex system that will satisfy certain pre-specified performance criteria. Falls under the branch of control theory that deals with design and analysis of multiple controllers that operate together to satisfy certain design requirements. Thus, it helps in the potential applicability of a design method for a distributed control system. Machine learning contributes anonymous entities, each having diverging interests or different information. Multi-agent perspective allows you to see a large system as a collection of smaller interacting parts. This implies that you have decided to use multi-agent framework uh, as a design strategy. As a result, the decision-making process for each single component is governed by a much simpler organization, um, uh, much simpler optimization issue than before. So to the core issue, the decision of other independent components helps helps the complex system to make the decision-making process more easier. So it takes the load from centralized system, um, that rather than centralized system, it distributes the load to all the agent in the system. So each one makes own their decision, which in turn helps to make the main decision. Um, to solve one thing we have to concentrate in machine learning is to solve the complexity and the distributed nature of control system. Multi-agent learning system, control system, it is based on the game theory method in which each participant gain or loss are exactly balanced by those other participants. As we can see in the picture, it's a picture of Guinness World Record. Uh, Guinness World Record held by the largest number of drones. As you can see, is a very good example of a multiple agent learning system where more than 3,000 drones uh, work in synchronized control system to create this imagery in the sky. Similarly, the game theory is the mathematical study of decision making, of conflict and strategy in the social studies, which helps explain how we interact in key decision making process. The game can be either one-shot game, a repeated game, or a stochastic game. Choosing one-shot game implies that we ignore the dynamics of the problem. A repeated game offers a research structure by reflecting the consequence of a strategy over multiple time steps, which suggests which suggests us to use the stochastic games, which are more natural models to handle dynamics. Moreover, uh, if we recall the reasoning for choosing multiple agent systems to design control system, important motivation for taking a multi-agent
Lama, sorry to interrupt you. Like your voice is bit inaudible. Can you check your mic once?
You are not hearing me?
Yeah, right now we can hear you.
Okay, sorry.
Yeah, please
You were
continue.
hearing me? Okay, I'll go again. We recall the reasoning for using multi-agent learning system. It is designed control system for taking multi-agent perspective to decrease the complexity in the system. So, which can replace for design consideration. The important task that follows is defining agent utility function. We have to specify the utility function for each agent so they can work in a group together and make the decision making process easier. Lastly, the Nash equilibrium. Uh, Nash equilibrium is a concept within the game theory where the optimal outcome of a game reflects the perspective of each individual component, but do not need to reflect the optimal operation from a collective. The optimal outcome of a game is where no player has an incentive to deviate their chosen strategy after considering the opponent's choice. Most of the work on the multi-agent learning is devoted by characterizing the limiting the action of various algorithm, which has to determine whether action follows the Nash equilibrium. Most of the work on multi-agent learning is devoted to characterizing limiting action of various algorithm, which helps to determine whether action follows the Nash equilibrium or some other desirable target set. Furthermore, we also have to keep in mind to put in the robustness and domain knowledge as a part of system design along with Nash equilibrium and game theory. Domain knowledge is the knowledge of a specific specialized discipline, professional, or activity in contrast to general knowledge. Currently available multi-agent learning algorithms are typically extremely simple and they do not take domain knowledge in account. While this might be appropriate for the specific agent, some engineering cell system allows the agent to use considerable resources than it requires. Thus, having a good domain knowledge help us to separate the knowledge, separate what resources each agent can use and what agent they can use, which helps to better simplify the system and help create better control system for using a multiple agent learning system. Oh, so I want to conclude that. We good? Yeah. Yeah, I'm good. You got the record? Yeah, my.